Hello, everyone. Welcome to our presentation. The title of our presentation today is Leveraging Users' Interaction Signals and Task State Information in Adaptively Optimizing Usefulness-Oriented Search Sessions. My name is Jiqun Liu. I'm Assistant Professor at the University of Oklahoma. This is joint work with Shirag Shah from University of Washington. So in this work, we're trying to achieve two goals. The first goal is to characterize complex search tasks from a process-oriented perspective. So basically, we're trying to understand task state distributions within each information search sessions. And for the second goal, we're trying to leverage the collective user interaction signals and task state information in helping users find documents that are useful for completing tasks, not just relevant to the topic. So in terms of motivation, as we know, in interactive information retrieval, we care about information search that are not just involve factual tasks that can be addressed with one query segments, but also we are interested in how people behave in complex search tasks. Search tasks like finding credible information about COVID-19 treatments, finding useful information for deciding a medical plan, and gathering information for PhD program application. So for these kind of complex search tasks, they often have no clear solution path or shortcut. And they often involve multiple queries and multiple search iterations. And they often involve higher cognitive loads, especially compared to the factual search tasks that involves clear predefined facts. So when dealing these kind of search tasks, users are more like walking in a foggy forest where they don't know what's going on in the long term within the whole search session. What they know is that the queries and the topics they are dealing with in the immediate query segments. Maybe they know what they need to do in the next query segments, but they don't have a clear plan for the entire search session. So which is part of the reason why in complex search tasks, they need more support from the systems. So in previous studies, there are many studies which investigated the impacts of predefined task phases, like task topic, task type, and task complexity, and explored their role in search interaction and search experience. So in this work, we're trying to go beyond that and look at what's going on during the search process, right? And especially in complex search tasks, what are states that users go through and what they're trying to do under different states and how we can support them under each kind of state. So based on that, based on the knowledge about their behavior, based on the knowledge about the state distribution, state transition, we can have a better chance to develop more useful state-based search recommendations. So corresponding to the two goals, we have two research questions to answer in this study. The first question is, how do users' task states vary during search sessions? And second question is, how can we leverage task state information and user interaction signals in developing adaptive search support for users engaging in complex search tasks? In complex search tasks, users often involved in prolonged search sessions where they try to achieve different things at different points, even within the same search session. And under different intentions, they have different task states, and they try to do different things. So they may need different types of support from the systems. So that's the basic starting point and motivation for our study. So to answer those questions, we did a user study where we assign search tasks to users and we collect their search log and documents they interacted with. Right? So in this study, for each participants, we asked them to complete 2 search sessions, and each session is 20 minutes. And based on the questions and requirements in the search task, they're asked to search for information which can help them fulfill the requirements in the search task. And during the process, we collect their search behavior data, their annotation about documents, and also their intention annotation for each query segment. So basically, we're interested in what exactly they are trying to do, what exactly they are trying to achieve under each query segment, not just within the entire entire session. So that's the the starting point for us to study task state in this research. So this is the intention annotation interface. On the main screen, we replay the whole process of the whole information search process for the user. And based on the replay, we ask users to annotate the intention associated with each query. So for each query, we ask them, to annotate what they are trying to do based on the predefined intention typology. So in the intention typology, there are 20 different intentions, and users are allowed to annotate multiple intentions if they have multiple things to achieve under the same query segment. So based on user intentions, based on the search behavior data, we did qualitative coding and also clustering. And based on those analysis, we extracted 4 basic types of task state. So each state describes what users are in general trying to achieve under each query. So we interpret each state based on the most frequent intentions under the state. So there are first is exploration state, where users are trying to basically identify something to start search. They don't expect to find the answer directly. And exploitation state is the state where they have a general topic to focus on, but they don't know exactly what they're trying to do. They're trying to search more information about this topic at hand. And no item state is the state where they know exactly what they are looking for. And learning and evaluation state is the point where they're trying to learn more domain knowledge, and they try to evaluate the results they collected, evaluate the correctness, evaluate the usefulness, evaluate the credibility. So in terms of research question 1, we did the density plot for the state distribution across different task types. And we found that in general, task state distribution varies across search tasks of different types, which allows us to characterize the different task types with the different task state distribution patterns. Right? So this is very different from many of the previous research where we define tasks only based on the predefined task facets. So in this way, we try to define and differentiate different task types based on the process of the process in which user accomplish those tasks. So basically, the task state distributions across different types. And we found that more queries and there are early peak points of learn and evaluate state in tasks with amorphous, intellectually challenging goals. So this is our answer for research question 1. So for research question 2, we're trying to develop, basically simulate adaptive search recommendations with the help of reinforcement learning algorithms. Now we have the knowledge about users' task state distribution transition, and also we have the knowledge about their search interaction patterns. And say, for example, for one user, we know the states they go through, and we know the query segments. And what we try to do here is to help the user complete the task sooner with less steps, with less queries. So how do we achieve that? In this work, we achieve that by extracting relevant and useful query segments from other users and recommend that search path to the current user, so that we can combine multiple useful search paths together, and those search paths jointly can reduce the steps needed for the original target user, right? So with the help from from the collective wisdom, the current user can can fulfill the task requirements with less steps. So that's what we're trying to achieve. So in terms of rewards, how do we evaluate the recommendations? So we basically manually annotated the documents users interacted with. So in search tasks, we clearly defined the requirements for completing the search task. So for example, in some of the tasks, we have several, 6 statements for which users need to find information to either confirm or falsify, right? So for each of the documents that user bookmarked or interacted with, we will annotate, how, for example, how many statements the page can actually confirm or falsify, right? So for example, here for this page, it can confirm statements 1 and statement 2 out of 6 statements in total. So we use a vector to represent the reward, right? So you can see the vector, the first 2 elements is 1, the rest of that is still 0 because the document cannot confirm or cannot confirm or falsify the other 4 statements, right? So we use this way to manually annotate the actual rewards or actual usefulness that each document can bring to the user. So we use this as the kind of ground truth label for the training purposes. And for actions, what actions the algorithm needs to take? The actions are actually, represented by different weight vectors, right? So we assign different weights to different search behavior features, including query similarity, dwell time on SERP and content pages, and content page clicking pattern within each query segments. So based on this, we design different weight vectors, which assign higher weights to different parts of these search interactions. And based on that, we rank different search paths, different query segments, and the top query segments will be assumed as the actual recommendation made to the target user. And then we evaluate the actual reward brought by the recommended search path. And different actions corresponding to different weight factors actually corresponds to different ways of ranking query segments. And the algorithm will adaptively change the action or recommendation strategy based on the actual reward from previous interactions. So this adaptive process is the main part of this reinforcement learning based search recommendations. So basically, as is shown in this figure, from the target user, the algorithm learned the state, and based on state, the algorithm take action, which ranks available query segments from other users under the same state, right? So we extract all the search, query segments under the same state as the candidate query segments, and then rank the query segments and recommend the top one to the target user. And the reward, the actual contribution, will be used as feedback to the algorithm. And so the algorithm, based on the actual feedback, can decide what the algorithm need to do in the next round, what action the algorithm needs to take. So based on this adaptive process, as you can see, after several rounds of iterations, the number of steps were significantly decreased after several rounds of iteration and improvements in the algorithm performance. Right? It's the same case for all the task topic combinations. And in terms of result evaluation, we found that simulated search sessions outperformed the 2 baselines in all task topic combinations in terms of reducing steps to completion. So that's our answer for RQ2. So for future directions, we are interested in, for example, studying search behaviors under different states and predict task states in real-time search. And also, we are interested in state-aware search evaluations. Under different state, users have different intention, different experience. So their search results should be evaluated in different ways. And beyond task stage, we are also interested in user cognitive bias and their effects on search interactions. And even beyond simulation and interactive IR, we're also interested in developing general level intelligent guided task support for not only search tasks, but more general information seeking and work tasks. And in some of the directions, as you can see, we have already developed, accumulated some preliminary results and publications. We are intended to, to make further progress on each of these sub-directions. All right, so that's all for our presentation. I'm happy to answer any questions you have.